Hello, everyone. Today we are going to discuss a couple of examples about vectors and the decomposition of vectors. A vector is a quantity that have both magnitude and direction, and also it follows the rule of addition for vectors. Uh, you can you can represent the resultant of two vectors actually by two rules. Uh, the fact is that it does not matter where you choose the location of the vector in the space. You can choose the starting point of two vectors in the same point. So then you're going to use the trapezoid rule for the addition of vectors. Um, so here we have P plus Q equal to R. Or you can choose the endpoint of one vector as the starting point of another one, and you're going to get the same result, P plus Q. R, actually, the resultant of the vectors are equal. It does not matter where you locate the vector in the space. So well, when we want to use vectors quantitatively, then we need to choose a Cartesian coordinate or any orthogonal coordinate. And well, in these examples, we are going to have two-dimensional cases. So if we choose a coordinate system with x and y, then a vector f could be represented by f of x and f of y in the x direction and the y direction uh, respectively. And fx is actually uh, the multiplication of the length of the vector and the cosine of the angle between that vector and the x direction. And same for y direction. We have fy f equal to f of y equals to f times sine of theta. Well, we know from trigonometry that in a right angle uh, triangle, if you have an angle theta, then sine of theta is equal to a over c, and the cosine of theta is equal to b over c. So, well, in the following example, we're going to use these two relationships to derive sine of theta and cosine of theta, and subsequently the two components of our vectors in the x and y direction. And we know that from the Pythagorean rule, we have f equal to square root of f of x squared plus f of y squared. And tangent of theta is actually the slope of the line that the vector lies on. This is also a useful equation. Okay, in our first example, we are going to decompose three vectors in three different regions of the Cartesian coordinate. Well, let's start with the 800 Newton vector, which is actually a force physically. For 800 Newton vector, as we had before, we have to calculate f of x as f cosine of theta and f of y f sine of theta. So for 800 Newton vector, we have to multiply the magnitude 800 and by actually cosine of theta, which is in this example 800 over 1000, and this is actually the hypothesis of this triangle here that you can calculate by the Pythagorean rule. So we are going to derive f of x and f of y with this procedure. So well, for next vector, there's a difference here. You can, I told you that you have to, if you want to use these two formulas, you have to have a theta that is the angle between the vector and the x direction. So for the second vector, 424, you have a theta like this. So you have to calculate sine of theta and cosine of theta by this angle. And this is the angle that a vector has with x plus. So this is these signs that you're seeing here is due to the fact that this theta is greater than 90. Well, it doesn't really matter which angle. You can take this angle and calculate sine of theta and cosine of theta, in this case, sine of gamma and cosine of gamma. But you should be careful about the sign. It is very obvious here that this vector has both minus sign in its x component and y component. So for f of x and f of y, we have minus 224 and minus 360. And well, you can calculate the sine of theta and cosine of theta like before. So for the next vector, here you should consider the fact that you have a angle theta here, and actually you should determine the sign by considering the fact that this is in the fourth region of Cartesian space. So the x for the component in the x direction is positive, and in the y direction is negative. Okay, so we are going to have a more physical example. We have a hydraulic cylinder BD that exerts force on member ABC. And this force is along the line of BD. Well, we know from this example that actually I can show you the P vector. This is the force that BD element is exerting on ABC. So it says that it has a 750 Newton component perpendicular to member ABC. So you're going to have okay. You are going to have you can decompose P into two perpendicular directions. We have the magnitude of this vector. This is 750. So it asks us to calculate the magnitude of force P. So, well, we have the geometry here. We have the angles here. So we can determine the sine of theta and cosine of theta, and then calculate the force P from its component. Well, actually, what I'm going to do here is drawing a free body diagram. So you're going to have a force you're going to have a force in this direction, and you're going to have the composition of them. Well, I'm going to consider this direction as X and this one as Y. All right, then we know that this vector, we can name it as P of Y and this one as P of X. This vector, the magnitude of P of Y is 750. So this is actually equal to, if you consider this angle as theta, this is going to be, Py is going to be P sine of theta. All right, well, now by this formula, you can calculate P by dividing 750 by sine of 20. Well, now we need to calculate the angle, the angle theta. We know that P is along the direction of BD. So if we know this angle, then we obviously know theta because they are equal. Well, you have 120-degree angle here and 40 here. Then this angle would be actually the sum of the angles in a triangle, 180, and you will derive 20 for this angle. So theta is actually 20, and you can calculate P with all you have. And well, next we should calculate Px. So Px here is actually P cosine of theta. And you have everything you can calculate. You can calculate the force in the x direction. All right, here we have a rope that has a tension in it, and we have a point that is actually the intersection of three vectors, three forces. Three forces are acting upon a single point. So these are vectors, and we can use the rule of addition to calculate the resultant of these three forces. Well, we know that the magnitude of all three. This is 500, 200, and this one is 365 Newton. And well, here we have slope. We can show the slope of a vector, but with this indication, it means that if you have a vector in this direction with length 25, then you can decompose it into two vectors in two perpendicular direction by the amount of 24 and 7. And same here. So this is actually the same as having some length for the directions and for the length of the vector. So it doesn't really matter. You can have the length of the directions, or actually the ratio of the decomposed vectors. So if you draw the free body diagram, we can choose xy coordinate along this direction, which y is along BC direction here. Then you can calculate the resultant of the forces in x and y direction. So first we need to decompose these three vectors into x direction and y direction and then add them up together. Well, for the cable force, well, we had these two dimensions, 960, which is along the x direction, and 1460, which is the length of the vector. And you should also notice the sign here. And you can see that the cable, which is in tension, has minus sign in the x direction and minus sign in y direction. So you can calculate the decomposition of this vector with fx and fy, and you can do the same for 500 Newton force, and you can use the ratio of components from here, 24 in x direction and 25 length of the vector. And same for fy, and you can do the same for 200, but you should notice that you have minus sign in the y direction. Well, now that we have forces divided into x direction and y direction, you can calculate the resultant by adding up each components from each vector in x direction to derive the resultant force in x direction. And you can do the same for the y direction. And well, you have the components of this vector in x direction and y direction, the resultant force. And by this, you can use the Pythagorean rule to calculate the magnitude of the resultant force. And this is the square root of 400 Newton squared plus minus 255 Newton squared.